Yeah, I wish I knew about the sushi ahead of time. I'm kind of full now. Oh well. Hey everybody, I'm Bryan from Netflix. I'm on the information security team focused on corporate security. So I won't really be going into any sort of application testing stuff. It's more infrastructure. Um, so I'm here to talk about our location independent security approach, or LISA. If you've heard of Google's BeyondCorp, it's a little bit like that. So as the name implies, it's a security architecture or security approach where we're trying to be independent of people's location. So in essence, stop trusting just because you're on our network, you have an IP on our network, we should not be trusting you and giving you any special access, essentially turning the network into your office network into a Starbucks network. It's just like any other network out in the world. Um, so instead, we're trusting authenticated users, their identification, two-factor authentication, and the health of their specific devices. And this shares some of these basic principles with Google's BeyondCorp, although Google's BeyondCorp goes off into crazy levels of detail that I'll mention briefly at the end. So why? So traditionally in corporate environments, people would be able to plug into your network and get access to other workstations on the network, local servers, hop over to your data center, all sorts of fun things. So we wanted to address that risk, and rather than putting in something traditional like 802.1x, we wanted to step back and look at the bigger picture and say, okay, well, how else could we address this, and hit on some of these issues that I'll mention in the next couple slides. So in Netflix, we have a lot of what we call freedom and responsibility, and part of that is we really like having an open campus. We don't want, guards and crazy fences and, like lasers and sharks and whatever. So we want people to have fairly easy movement about the campus. So rather than focusing on physical security, we then focus on logical security. We also want people to be able to work from anywhere without geographic restrictions, so you have the same experience in Tokyo or McDonald's or your home office as you would in the corporate office. And also, all the cool kids have been saying it for a while, the perimeter is dying or dead, so we wanted to help put another giant nail in that coffin by taking away another part of that perimeter, which is traditionally the office network. Benefits, so reduced attack surface, so you don't have to worry about people coming into your building and plugging in one of those traditional attacks. Help stop man-in-the-middle attacks. I've had people ask me, what do you guys do on your network to help against like ARP spoofing and man-in-the-middle attacks and all this other stuff? And well, now with this in place, we don't really have to worry about that. Everything from like layer 4 or so on down, we don't care if you man in the middle us. We've got other protections to get around that. And because even if we had those protections on our corporate network, they wouldn't protect the user when they're, say, at Starbucks. So we wanted something that would work in both locations. This also provides a convenient choke point for authentication, access, and inspection. So rather than doing this at scattered places around the network, around the environment, the enterprise, you can do it in one central spot. And it also allows you to do endpoint checks for the health of the device, doing inventory, doing patching, checking all sorts of health-related things. More benefits, simplified network architecture. We wanted to help clean up our network and keep it as simple as possible, and have one solution that covers users, as I mentioned, inside the office and outside the office. Also, we have some locations where it's just a small office in the middle of nowhere, and we can't put in a giant network stack that we might want in one of our corporate offices. So we want to protect those users as well. And because you're not having giant security stacks scattered around your environment or at different offices, you've got cost savings, which is always nice. And this is all commercial off-the-shelf software. We're not doing any custom development, with one small exception I'll talk about. So since it's all commercial off-the-shelf, you just bolt it together. You're not doing any custom development, and I don't know if you're like many other companies out there, you don't have a dedicated team that you can, like your IT department doesn't have dedicated developers or people they can steal from production to help develop custom code to do all this sort of stuff. So you're saving time and resources there. And also because you're not doing custom development, you're not tied to a specific set of supported vendors. So if you swap out, like say your network stack or your VPN stack or whatever, or your endpoint health checks, it doesn't matter. You don't have to rewrite any code. So endpoint checks. At Netflix, I mentioned that freedom and responsibility thing. So we encourage people to MYOD. I thought I made up this term, but apparently not. I Googled it. Someone else mentioned it a long time ago. So manage your own device. So people can bring their own device or they can get one from us. But instead of us tightly controlling that system, we want them to have the freedom to do whatever they want and run whatever software they want, do whatever they want. And the responsibility of that is you have to make sure your system's patched and up to date and healthy and everything. So to let people do that, all this data from the different parts of Lisa feed into what we call user-focused security. My homie Jesse right there presented on stethoscope and possibly in the future on TrainMan, presented on stethoscope at ShmooCon recently. So check out the talk there, awesome stuff. I got a link here. I can give you the link later. And we've also got a Netflix tech blog on it. So what that allows us to do is when the user connects in, it takes an inventory of their system and says, okay, you know, your system's up to date or not. Here's how you would go ahead and fix it. And lets them do that themselves rather than us tightly managing the system. And then for people who don't frequently get on VPN, our 2FA provider and Google Auth, because we're Google Shop for everything, also have some health-based checks for those SaaS users that don't usually need to use VPN. So here's a quick screenshot of stethoscope. This was some of the custom code I was mentioning where we wrote this custom app. I mean, you don't need this for Lisa, but to help with our environment of having people do everything themselves, we did create this tool. So the basic idea is user logs in and they see, oh, here's my iPhone, here's my laptop, here's my other laptop. Oh, I didn't know I had this laptop. Okay, well, anyway, I can junk that one. So my main laptop, it's good, but say it doesn't have patches installed or maybe disk encryption is installed. So then you're able to click on it and say, oh, okay, well, here's why these updates are, here's why an update, you know, auto updates are important, and here's the steps to do it yourself. Methodology. So the basic building blocks of Lisa were, like I mentioned earlier, the office network really only gets internet access and VPN. You don't get any special access to anything when you plug into our corporate network. There's also device isolation, which if any of you got hit by the recent Samba exploits, this is nice for that, so that hosts, if something gets popped, it doesn't spread around your network. So host-to-host isolation and also network-to-network, subnet-to-subnet isolation. And then private resources like Amazon, because we're an Amazon shop, or your data center are only accessible via VPN. You could also, in theory, use something like SSL, like Google's doing some SSL proxies if you want to go that route. So more methodology. So don't forget that just because you're deprivileging the office network, there might be still places where that network's trusted, like say, oh, because you're coming out of the building's public IP space, it's natted out. Maybe over in Amazon or some other provider or somewhere, you're saying your application sees, oh, you're coming from the corporate building. Even though the building's been deprivileged, I still trust these IPs as you come out the internet interface. So I'm going to allow you some special extra access or bypass auth or what have you. So don't forget to check for whitelists in your applications and your resources and things. And oh yes, redundancy and circular dependency is always a fun one. So don't forget that if you're channeling everybody into one or a couple redundant access points, to have them geographically distributed and everything. So, you know, if you're having everyone come into one VPN access point, make sure you've got a couple of those. And then also, what if your VPN box goes down? Or what if your auth provider goes down or something like that? So you may want to have a physically secure room on campus where you can bypass some of these in case of emergency. Collecting use cases. So we didn't really want to send out a blast email to the company because, you know, one, people ignore those kind of emails. Two, they get annoying. They just get lost, whatever. So we actually went kind of like a gumshoe sort of sleuthy method. So I actually went out and I had to get out from behind my computer and talk to people. It was a little scary. Talking to directors and VPs and, you know, longtime employees and people in the basement, like with suspenders and stuff, all the people that have all the hidden knowledge around the org, and saying, hey, here's what's going to happen. Here's what this project is. Here's why we're doing it. Here's how it might affect you. How do you think it's going to affect you? How do we need to maybe change your workflow a little bit without, you know, making your life totally miserable? Do you know of anybody else that might have this issue? And then that leads into all sorts of interesting like breadcrumbs and trails and fun rabbit holes to go down. So luckily, after we did this research phase, we found most employees only needed internet and VPN access, so awesome. But there's a couple of use cases that were causing some problems. So I don't know if you've heard, but Netflix has this cool app that like lets you stream movies from TVs and devices and things. So the only problem with that is if you're in the building and you need VPN access to get to any sort of special resources at Amazon, like say your test harness or your code repositories, and the code's running on the TV or your Roku or your Apple TV or whatever, there's no VPN client in a Roku or a TV. So of course we had to make a couple exceptions. So yeah, for these consumer electronic devices, they need to talk to private resources up in Amazon. And on occasion, some of them, people will be developing code on their laptops and they need this test TV to connect to the code on the laptop. So that also violates that host-to-host block that we were talking about. So creating exceptions. Our network one has limited Amazon access. So for testing CE devices, like I mentioned, test harnesses and getting code that you need and pushing code up. And our other network is full Amazon access. So this is more like the traditional environment, like before we had all the stuff in place. And there's only a handful of people on that, luckily. So that's usually to deal with things like VPN client limitations, because let's say, oh, maybe your provider's Linux client, VPN client doesn't have all the feature parity that say like Windows and Mac do, which would never happen. Or say you've got some high throughput situations, like you've got video tester guys with data science-y people testing algorithms on giant gigabyte, terabyte files of video on their desktops, and they need to have just giant pipes to their desk. So yeah, with these two networks, we review access requests, track, and automatically deprovision them when they're not being used. So since these are exception networks, we want to tightly monitor and control them. Long term, these will go away. We're working on some small little Linux gateways so that you can have this box at your desk, and if your TV or whatever doesn't have a VPN client, you auth into this box, and then it'll connect up to Amazon with a VPN for you, or you can take it home, get the same access there, wherever you happen to be. So here's a visual diagram for us visual learners like myself. The basic principle is, so here's your typical office network. So you've got your user. The first thing they would hit is the private VLANs, which does the host-to-host isolation. Then you've got the firewall ACLs for the subnet-to-subnet limitations. And then going over to, via VPN, over to your private Amazon resources, you've got your VPN concentrator, and the actual client health checks are happening on the VPN concentrator. And then you've got your IDP and 2FA for verifying that the user is who they say they are aren't just using some stolen credentials or something. And then you've got your main network security stack where you do all your traditional network-based inspection stuff. And then you go out to the internet or into your private Amazon resources. And then let's see, this is just a diagram here of the allowed flows. So workstations can get out to internet and VPN and then over to private resources. You can also come back down into devices on the local network. And then on the exception networks, you can talk directly to a small subset of Amazon and can talk device to device. And then here's the basic idea of host to host isn't allowed, subnet to subnet isn't allowed, and then direct access to private resources is not allowed. So pilot networks, it's always good to test ahead of time rather than just throwing one giant switch and having the building catch on fire or having people like slash your tires because you ruined their day. It's best to have like a small little subset of people to test things out, work out issues, tuning the workflows and documentation, like, oh, we forgot step 5A or step 6 doesn't quite work so well with Linux, we need to tune that or have some workaround. And then, of course, always finding hidden use cases, because no matter how much you've communicated with people and tried to find all those use cases, there's always going to be something you didn't find or they forgot about. They're like, oh, yeah, I forgot about this one thing, but that only happens like once a quarter. Yeah, so all that kind of stuff. Automated deprovisioning. So this is just a quick description of how we do the automated deprovisioning. So just talking over API to our network switches and saying, hey, who's on this exception VLAN? The interface description says, okay, here's the jack number. And once we have the jack number, we can match it to cubicle number. And then from cubicle number, we can talk to Workday, our HR database, and say, who's in this cubicle? And then email that specific user and say, hey, are you still using this? Or, hey, this hasn't been used in, say, a month. Can we automatically deprovision it? You know, hit yes or no. And if they don't do anything, then we can automatically deprovision. Communication. So at Netflix, typically what happens, I'm oversimplifying here, but when we have a new big idea like Lisa or some other strategic initiative, we'll put together a memo spelling out, okay, here's the general idea, here's why it's good, here's why we went this way, and then we'll have a tech strat where we get together and debate, okay, how else could we do this, or what are the merits of this? Is this worthwhile? Is there some other way we could do this? That kind of thing. And then once we settled on this approach, it gets communicated then from the VPs down to their teams and then to the individuals from there. Always make sure that you pull in the right teams. So for this one, we made sure we had the security teams involved, the network team involved, because they're of course doing all the network changes, the help desk, because they're going to deal with the users that might come in, and then the people that are going to be affected most, the different teams that it's going to affect their workflows, or people on the exception networks. So different ways of communicating, since we had to get creative, since we weren't just going to send out a blast email like I mentioned. So we had to do targeted emails of finding out all those use cases, then emailing those specific groups and departments saying, hey, for your specific group, this is going to happen. And then setting up flyers in strategic locations to hopefully catch everybody. And what is the one strategic location that everyone visits every day unless you're some sort of freakish camel? The bathroom. So that worked well. We also had a Google group. We had a Slack channel because we're Slack shop for the most part. We had a question and answer doc where people could post questions and answers. We had a website. We probably would have taken questions over postcard if we could have, like any method possible. And then we had town halls where it was basically in this room, and we announced, hey, if you have questions about Lisa or concerns, come talk to us. It went well. I made it out alive. And then we also had office hours every week. Kevin, Nog, you remember these, good times, where you would post up in the cafeteria and put up a sign and say, hey, these are Lisa office hours. It's scheduled every week from 1 to 2 or whatever. Come ask any questions. And then we also had a day of we had a war room down at the help desk so that when people would come into the help desk, we were right there with them, seeing, kind of like having our finger on the pulse, so to speak, getting everybody in the same room, those teams I mentioned, like security and the network team and help desk and all that. And then it's time to go live. Did you get everyone? Are you sure? And yeah, you think you get everyone, you do all you can, and then there's always that one guy that, like the guy that a couple days before we went live, he comes up to me and he goes, Brian, what's this Lisa thing I've heard about? I was like, you didn't see the flyers? He's like, oh yeah, I saw the flyers, but I didn't read them. I shed a tear. It was hard. So at our Lisa office hours, I put up this poster to try to get people's attention. I also had a little stack of beer to like entice people in. They're like, oh, free beer. Maybe I should learn about this thing. Unfortunately, it was mostly my coworkers that came around, but at least they helped drink the beer. And then branding. Every cool project at Netflix, especially the open source ones, have to have some sort of logo or mascot, a giraffe in the case of Stethoscope, or just cool logos. So one of our internal UI guys, I had him do up a logo. He actually did the Spinnaker logo too. You can see a big resemblance there. So that helps with tying the messaging together, like when they see the flyers, when they see the email, when they see the website, when they see stickers on laptops, my tattoo, what have you, they get the messaging all tied together. They know this is all part of the same project. So beyond this is where I tie in BeyondCorp a little bit. So as I mentioned, it's similar principles to BeyondCorp, where you're deprivileging the Office network. You're instead trusting users based on their identity and the health of their devices. So Google goes, of course, as Google does with their bazillion developers and PhDs, to the next level. And so you can read their white papers on this stuff, and it's awesome. Like, it's a superb architecture, but it's a lot more custom. It's a lot more work, custom code and everything. They also have very tight endpoint controls. And I read somewhere that like even if you swap out the RAM chip on your motherboard or whatever, like it revokes the cert because it's like, oh God, this might be like a new system. We don't trust it. I don't have all the details on that, but that's what I read or what I understood in the white paper. So it's definitely a bit more, yeah, not really so Netflixy. So we wanted to go something a little more friendly. And they also put proxies instead of their apps. So basically they make their internal apps web accessible rather than using VPN. So there's of course always trade-offs to VPN or to the proxy approach. So pick whatever floats your boat. And yeah, so Lisa has similar principles, but a smaller feature set compared to BeyondCorp. But it could be a stepping stone to BeyondCorp because we are actually, maybe the next step, we're looking at possibly doing the SSL proxy approach rather than VPN just to get better performance and impact users less. That's it. I'll take questions outside.